Okay, continuing on, we just talked about conditionals, but so far we've still been using very simple data structures. So data structures are this idea that sometimes we don't just want one number all by itself or just one Boolean or something like that. We want to be able to structure them together in some more interesting, complicated way. This happens in engineering all the time. Think of a test matrix. So you need to run a certain number of cases. It'd be nice to kind of bundle all of those cases together into one object so you could use them all at the same time. And that's the kind of example we're going to have below. So very commonly used in engineering, really nice. The simplest data structure in Python is a list, and it's a good place to start. We're going to switch and talk about other ones like arrays in the next video, but for now, let's just get a handle on lists, okay? So let's build a list at first. The most simple way to do it is just to write out all of the things you want grouped together, put them inside square brackets, and put a comma in between each one, okay? So here's a list of the first few primes, and I can see that that gets spit out as the list, and kind of the way it prints is exactly the way I put it in, except for some spaces, okay? I don't need it to be numbers. I can also make lists of anything I want. So here's a list of single name singers. So we've got Prince, Pink, Eminem, Rihanna, Madonna, and Beyonce. All right. You can make lists of whatever. So you could make lists of potential weather conditions you're worried about in engineering, or different kinds of materials, or whatever. Okay. So there's a lot of options for where you might want to group together a set of information into a list. All right. So far, so good. We can also make an empty list. So if we just don't put anything inside, that's fine. Python's happy to start. It kind of sets aside the name empty, and then it lets us fill in that list later if we want to. Okay. We've already done for loops on the range object, and the range object kind of sets up an automatic list going from 0 up to the number of things that we asked for in range, right? So now we can do the same kind of thing for a given name in this list of single name singers. So one of the best things about Python is how readable that is for name in this list of singers. And what happens? It prints out each of those names in order, just like we want. So that makes perfect sense, and it works very nicely. We can even be a little more complicated. So here I've made a new list of household ages. So these are the ages of all of the animals and children in my house. I have too many things living in my house. And so we can check if any of those are prime numbers. So first I loop through the primes. So for P in this prime list, that's going to give me a list of P's, right? Then, or not a list, it's going to give me a P and it's going to increment through all the choices. Then as each choice comes up, I can check if P is in this new list of household ages. So it lets me check if one thing is in another list. So again, we could imagine this in an experimental setting. We've got a list of materials that we're worried about. Here's a list that we got from a website. Is one inside the other? This would be a way to do that kind of thing. So in this particular case, there's two numbers that are primes and the age of something living in my house. All right, so that's a nice little handy way of doing it with a nested for loop and if statement. All right, so far in these examples, we've gone through all of the items in the list, and then we use the if statement here to only do a couple. But we could instead just look at a sub list, some part of the whole list. It's not super common in engineering, actually. Sometimes it is, though, so it's good to check. So first thing to remember is that Python uses the zero-based numbering system. That's why when we said range 5, it started at 0 and went up to 4, actually, not including 5. So it gave us 5 numbers starting at 0. That's also the way indexing works here. So for example, primes, if I want the first thing, then I don't type in 1, I type in 0 because we're starting at 0. So I say primes, square bracket 0. Again, we're not saying equal. This would be setting primes equal to something. We want to grab the 0th thing, the first thing, which is at the 0 index. And then this will be the second thing, which is at the number 1 index. So based on that, how do I need to change this to look for the last item? So I want you to fill this in. So what should I put in here where I've put the question mark? What needs to go in there to get the last item on the list of primes? So looking at our list, we just said it was index 0, 1, 2, 3, 4, 5, 6. So 6 should be the last one. We have 7 numbers here, just like range. That means we go up to but not including. So 6 should be the last one. And that should give us 17. Great, it works. What happens if we put in 7? Let's check. We get an error because we're out of the range that's defined in the index of the lists. So 6 is it. Okay, so getting familiar with that almost always trips people up at first, but it's good to get a hold of. We can also go backwards through a list. So before you click play on this one, what do you think this is going to give you? What's prime minus 1 going to give you? What do you think? All right, let's see. It gives you 17, and then prime minus 2 gives you 13, right? So it's like we're counting backwards. So we did 1, 0, and then as we go to -1, we're looping around. So this is index 1, 0, so -1 would be here. And if we loop around kind of Caesar shift style, then we'll get to the last one. And if we keep going backwards, we can go all the way through this in reverse, okay? That can be pretty handy. Also, we don't have to get just one at a time. We can do what's called slicing. So this grabs a section of that as a sub list. So really similar format to the range function. We can specify the start, the span, and the step in that order, same as range. In this case, it's not a function, so you don't pass it with parentheses. Instead, you put colons in between them. So those other two are optional. That's why I put them in square brackets. So if I just want the first 3 singers, I can do this colon up to 3. That gives me the range of numbers from 0 and up to 3 numbers. So that's the first 3 items. If, on the other hand, I did 2 up to 6 and skip every 2, then I'd get these. Okay, so that's the one at index 2 and then also at index 4. So we don't include index 6. Just like range. All right, so you can do these 2 exercises on your own. So I want you to slice to give the last 3 singers. How do you think that one's gonna work? There's more than one way to do it, actually. And then how about slice to give every other prime starting at the number 3? So I want 3, 7, 11, so on. Okay, so why don't you work on those 2 on your own? It should be pretty obvious if you get this right or not. So you can check your work. Cool. So next we can start talking about things you can do to lists that you couldn't do just to one number. So there are certain functions that you can apply. First, there are kind of standard function stuff. So we can take the length of a list, that's len. We can sort a list, that's the function sorted. We can get the sum of a list of numbers or the max of a list of numbers. All right, let's take a look at what those give us. So the length just gives us the number of items inside. So again, if we had kind of a range, that would be the same. So this is 6 for singers, and we can count them and make sure, yes, that's 6. Sorted, of course, sorts them. Since this is a list of names, strings, it sorted them alphabetically. If we gave it the list of some random numbers, it would sort them numerically. The primes are already sorted, so it's not a great example. So that's why we've done single name singers, okay? And we've got the sum of all the primes that we've got in that list is 58, and the maximum value was 17. And then finally, just like strings have that format method kind of built into them, attached to them, there are also a couple of functions that are attached to lists automatically. So for instance, this is just an example. There's a method called index. So this basically searches through the list looking for whatever you put here. So in this particular example, I've said, for the list primes, find the index where the number 7 lives. And so it says that lives in index 3. So we can go up and check if that makes sense for us. So we've got 0, 1, 2, 3. Yes, so the number 7 is at index 3. And then we can kind of double check that here also. So this is basically like an assert statement that I had before. So tell us what that index was, and then double check that that worked. If it works, then when I pass in this index you gave me, then the value should be the number I asked for. So, and indeed, primes index 3 does equal 7. Okay, so that works out very nicely. And again, that's kind of pretty much the same as the format statement. And we will see this kind of method stuff a bunch when we start doing libraries. So it's worth getting a little bit of exposure. All right, I think the last thing about lists we need to do is figure out a better way of making them, because making lists by listing all of the things individually isn't a very good plan when we have a lot of things. So for instance, there's a few ways of doing it. So here, I'm defining lists using repetition. So the multiplication for a list is different. And actually, we've seen this before. We did high times 5, and it gave us 5 highs. Now, you might have thought that now this is a number, like 4, I should just be able to get 5 times the number 4. But it doesn't do that. For kind of distributing operations through lists, we're going to have to wait until the next lecture and talk about arrays and NumPy. So instead here, we get 5 4s. And here we get 4 5s. Okay, this can be a little bit confusing though. So I don't recommend doing it this way. I more show it to you as something to be scared of. Don't do this. Use arrays instead. We'll talk about them. So another thing we can do is we can append lists together. So if we have this list A that we just made, we can add, the number A to it as another item by combining these two with a plus operation. And then we could do A plus B plus A as another option. Okay, this is again that operator overloading. We talked about that in the last videos where we talked about the fact that divide or multiply gives you different things depending on what you do, and same with add. So these two have kind of a weird list special meaning when you deal with lists, and so you need to be careful about that. Okay, I really don't recommend it. I think that's a bad way to make lists. It's not very readable. It seems confusing to me. What I really recommend is something called a list comprehension. So this is like a built-in for loop. So what we're doing is we loop through some simple list, and as we grab each of the items in that simple list, we use it to build some new list that we want. So this is an example. We're finally going to get to this example here, again, now with lists. So let's say we have a list of omega values. So here you can see we're making that as a range starting from 1 and going to 20. So this is going to give us 1, 2, ... all the way up to 20. Right? So that'll be our omega list. And then we can use that to get a list of wavelengths. So instead of having to do this for loop and kind of print them to screen, that's probably not what we really wanted. What we really wanted was to have that value of omega wavelengths from the value of omega. So here we've done that. And you can see the syntax. We still use square brackets, one on each side. But now instead of putting in each number, because we don't know the numbers, I guess we could have put in deep wavelength 1, comma, deep wavelength 2, comma, and all the way down. That would be very painful, right? So this is a way of automating that. So we want to go through all those one by one. So we do for omega in omega list, and then we just say what the value is that we're interested in. So give us this thing for all the items in this list. So that's the way comprehension statements work. They're really convenient and I think pretty readable once you get used to the idea. So here we've done that, and we can see we have a whole range of wavelengths. Now we know that some of these aren't valid because we haven't put in an if statement yet. So we can do that, but we'll do it in the next step. Okay, before we talk about that, let's look at another way to make the same list. So we could have started with an empty list for wavelengths. Then we could have done that for loop. We could have taken that empty list and we could have added on deep wavelength for this particular omega. And then it'll do the next omega and the next omega. And since we know that that just keeps adding on the new items in the list, then that'll work. In fact, I think I need to put a square bracket in here though, don't I? There we go. All right. So this should work, in fact. We should be able to add those things up together and get the list. But I find this to be much more confusing. There's another way you can do that uses an append method. So you can append things on, which does exactly the same thing. Neither one of those, I think, is a very good idea. It's way more work. And I think this is a little bit simpler. In the next one, we'll talk about NumPy, and we can do things even easier. And of course, that's the one I recommend when possible. But if you need to make lists, then list comprehensions are your friend. So I recommend doing it like that. Here's another example. We've got frequency list. So we're just going to convert from radians to hertz. So the conversion for radians to hertz, right? We've got 2 pi f equals omega. So we'll just divide by 2 pi to get all of our frequencies in hertz, cycles per second. Okay, so that's what we've got here. So we do exactly the same loop as before, except now we're applying a different function to get a different output, a new list. All right, so here's our set of frequencies. We're going from 0.15 to 3 hertz. And then finally, we can join those two lists together. So I don't want to join them on end to end, because that would just give me a list of two things separately. This new function zip is really nice. You give it two lists, and it will feed you back both of the first things, and then both of the second things, and then both of the third thing. So it's like having a little table of two items, yeah? So it'll give me the matching sets of the frequency in hertz and the corresponding wavelength. And then we can use those to do a test. So when the wavelength is less than 6 meters, because we know that was our double, this is the same condition we had before, 2 times our 3-meter tank. So that's the right condition. And also I'm going to add another condition, which is that I don't want this wave maker to go to very high frequency because it might break. So I'm going to do frequencies less than 2 hertz. So within that range, it turns out we only have a certain number of potential frequencies I should set my wave maker to, and here's the range of wavelengths out that I'll get. Okay, and this is the sort of thing you could then put up, print out next to the wave maker to make sure it doesn't break. All right, so now it's your turn. Time to do an exercise. So here's a real life problem that we have with our facility. So we have a finite length for this test tank. So here's our length of 130 meters. And you might think that that 130 meters was somehow a typo. No, no, no. So here's a little interactive plot. You can see this is our tank here. And this door comes in about halfway through. You can just barely see the far wall, but maybe it's a little easier to tell how big this is if you look the other way. So yeah, this is a 138-meter long tank actually. And I'm asking you to make a couple of different lists to help me design an experiment. The first thing I want is for you to tell me how fast each of these waves are. The formula is very simple. It's just the wavelength times the frequency. So that's a certain length per the amount of time until the next one comes by. So that must be the speed. So that's the first list I want. Then the next thing is I want to know, based on how fast they're going, how long will it take for it to reach the middle? So the reason why I want to know how long it will take each wave to meet up at the middle, that point where we were standing in that picture back and forth, is because a really fun demo and a way to test really big waves isn't to make one giant wave, but to make a bunch of waves of different lengths and all small amplitudes, and then have them all add up together at the same place at the same time. And if you do that right, you can get this huge wave that turns into a breaking wave. And you can see how the structures work under breaking wave conditions. But for that to work, I also need to know when I should run each of those waves. So getting the time delay from some starting time, so say go, so maybe the first one is at time 0, and then when should I do the next one, and when should I do the next one, and when should I do the next one, for this range of frequencies here, if I want all of them to add up at the same time at halfway down our tank. Okay, so that's your exercise. Not trivial, but a really good way of playing with Python. Good luck.